Hello, in this video I will go over lesson 16 practice problems. Number 1, the volume of the cylinder. So we have a cylinder, so the volume of the cylinder is 175 pi cubic units. What is the volume of a cone that has the same base area and same height? So recall what we know about the relationship between the volume of a cylinder and the volume of a cone that have the same base area and same height. So we learned that the volume of a cone is 1/3 the volume of the cylinder. And we know that taking 1/3 of something means dividing it by 3. So we can rewrite this as a volume of cylinder divided by 3. So we will use that to figure out the answer to this question, to figure out the volume of the cone. So the volume of the cone is the volume of the cylinder, which is 175 pi. So 175 pi, and then we will divide that by 3. So in your calculator, you can just plug in 175 times 3.14 for pi, and then divide it by 3. So the volume of this cone is approximately 183 cubic units. So that's the volume of that cone. So remember, the cone is 1/3 the volume of a cylinder that has the same base area and same height. Okay, problem number 2. A cone has a volume, so we're talking about cone, has a volume 12 pi cubic inches. Its height is 4 inches. What is the radius? Okay, so the height is 4 inches. So when you are solving a problem like this, always get started by sketching your diagram. So we're talking about a cone, so you sketch a cone, draw an oval, and label your radius. So that's the radius, half the circle, and this is the height, which is 4. And the volume, it's telling you it's 12 pi. The height is 4. The radius is, we don't know. That's what we're trying to find. So always get started by writing the formula down. So the volume of a cone is, remember, it's just the volume of the cylinder divided by 3. So the volume of the cylinder is area of the base times the height, and then divided by 3. After you have your formula down, plug in what you know. The volume is 12 pi, so instead of writing V, I'm going to replace that with 12 pi. I'll bring down pi. R squared I'll bring down because that's what I'm trying to find. H, I will replace it with 4 because the height is 4, and then all over 3. Okay, now this is just a simple solving equation now. You want to solve for R, so that means you have to get rid of pi, you have to get rid of 3, you have to get rid of 4. So you do it one at a time. First, you get rid of 3. The operation here is division. This fraction bar, that means division. So to undo division, you will multiply both sides by 3. So 3 here is gone, it's only 1. So on the right side, you only have 4 pi r squared. On the left side, you have 3 times 12 pi, which is 36 pi. Now you want to solve for r, you have to get rid of 4 pi. This is really 4 pi times r squared. So we will divide both sides by 4 pi. So 4 pi, that's only 1. Now you have r squared. And then on the left side, pi is gone. 36 divided by 4 is 9. So now again, you're going to ask yourself, what number times itself equals 9? So the answer is r equals 3. So the radius of that cone is 3. And remember, the other way of doing this, if you can think of that number times itself is 9, you can take the square root of both sides. Square root of 9 is 3. Okay? Alright, problem number 3. For problem number 3, you are given a cone. So we're working with cone again. And it's telling you the volume is 3 pi. So there are several questions here. They're changing the radius. As you can see, they're changing the radius. And then they're asking for the height. So let's see. If the cone's radius is 1, what is the height? So let me clear this up here. So for A, so again, I'm going to write down V equals pi r squared times height divided by 3. The volume is 3 pi. I'll bring down pi. The radius is 1. The height, that's what I'm trying to find. And then divided by 3. So if you take a look on the right side, you're solving for h, so you have to get rid of pi and you have to get rid of 3. So you want to undo 3. This is division. So to undo that, you will multiply both sides by 3. So now you're going to have on the left side, you have 3 times 3 pi, that is 9 pi. And then on the right side, 3 is gone, you only have pi h. Because pi times 1 squared, that's just pi. And then now, solve for h, get rid of pi, divide both sides by pi. So h equals 9. So the height of the cone with a radius of 1 is 9. Okay, let's do B. So now the radius now is 2. So again, the volume is 3 pi. So I have the formula here. So volume is 3 pi. And then pi times 2. Radius is 2. 2 squared times height divided by 3. We will do the same thing as what we did here. We multiply both sides by 3. So now you're going to have on the left side, you're going to have 3 times 3 pi is 9 pi. On the right side, that 3 is just 1. So now you have 2 squared, that's 4 times pi. It's 4 pi. And then h times h. Solve for h, divide both sides by 4 pi. So on the right side, you have h. 9 pi divided by 4 pi. The pi is gone. So the height is 9 over 4. Or approximately, if you change that to decimal, 9 divided by 4. That is 2.25. Oops. 2.25. Excuse me. So the height when the radius is 2 is 2.25. All right. Let's see here. Oops. Okay. Letter C. Now, the radius is 5. So again, V equals, so the volume is still the same, it's 3 pi equals pi times the radius, 5 squared, times the height, divided by 3. So again, multiply both sides by 3, because I want h to be by itself. So I'll show that. So on the left side, you have 9 pi is equal to, this 3 is just 1. You have 25 pi times h. Because 5 squared, that's 5 times 5. Now you have to solve for h. You have to get rid of 25 pi. So you will divide both sides by 25 pi. When you simplify, 25 pi is gone. You only have h. And then on the left side, pi divided by pi is gone. Then you can approximate this. 9 divided by 25 is 0.36. This is very small, only 0.36 height, because the radius is bigger. So then the height is shorter, right? Okay, letter D. For this one, the radius is 1/2. What's going to be the height? Think about it. What's your guess? Now, the radius is real small. It's only 0.5. So the height, it has to be a lot taller than the previous one, than this one, right? Because they still have the same volume, but this time the radius is a lot smaller. So let's figure it out. So the volume is 3 pi, still the same, 3 pi, and that's equal to pi radius squared. The radius now is 1/2, so I'm just going to write 0.5 squared times the height divided by 3. So again, solving equation, you have to get rid of 3, multiply both sides by 3. So that's gone. It's only 1. On the left side, 3 times 3 pi is 9 pi. On the right side, you have 0.5 times 0.5. So 0.5 times 0.5, that's 0.25. Don't forget your pi. So 0.25 pi times h. We're solving for h, get rid of 0.25 pi. So we'll divide both sides by that. So on the right side, that's gone. You have h equals, the pi is gone. 9 divided by 0.25 is 36. As you can see, this is very tall, 36 units, because the radius is real small. So this is a very skinny cone. Okay, the last one, E. So now they just want you to use R for radius. So you will just solve for R. I mean for the height in terms of R. So let's do it. So the volume still is 3 pi equals pi. Instead of R will stay as R because that's the value R. So R squared H divided by 3. So we will do exactly the same thing that we did here, like the 4 previous problems. We will undo this division by 3 by multiplying both sides by 3. So 3 times 3 pi is 9 pi. This 3 divided by 3 is just 1. So I only have pi r squared times the height. Now I have 1 to solve for h. I have to get rid of pi r squared. So I will divide both sides by pi r squared. So on the right side, this is gonna be gone. You only have h. This one, when you simplify, pi is gone. You're left with 9 over r squared. So that's gonna be your formula for your height when the volume is 3 pi. Oops. Okay, next. All right, problem number 4. This is a long problem. Let's read it. 3 people are playing near the water. Person A stands on the dock. Person B starts at the top of the pole, and zip lines into the water. Person C climbs out of the water and up the zipline pole. Match the people to the graphs where the horizontal axis, so this is the horizontal right here, represents time in seconds. So this is time in seconds, and the vertical axis represents height. So this is the height, the vertical, above the water level in feet. So let's see. So person A stands on the dock. So that means he's not moving. So the height is not changing. So time passes by, he's just standing over there. So the height is still the same. So that means this line here, this is person A, because the height is not changing, right? Person B starts at the top of the pole, so and zip lines into the water. So this is person B right here. So this is person B, this one. So we only have one line. So then it says here, person C climbs out of the water. So this one is starting below the water level. So it's right here. So this must be person C. Okay. All right. Problem number 5. Problem number 5 again is a word problem. So let's try to underline and circle key words. So a room is 15 feet tall. So we're talking about a room here. So there's a room 15 feet tall, and an architect wants to include a window that is 6 feet tall. So we have a room that is 15 feet tall, and the architect wants to include a window that is 6 feet tall. Okay, so imagine that. So here I'm gonna sketch it. We have a room. The window is 6 feet tall. Pretend that's the window. So this is 6 from here to here. That is 6 feet. The distance between the floor, so this is the floor right here. This is the floor. And the bottom of the window is B feet. So from the floor to the bottom of the window, that is B feet. So we will use letter B to represent that. The distance between the ceiling, so this is the ceiling right here, and the top of the window is A feet. So from the top of the window to the ceiling, it's A feet. And remember, the height of the room from floor to ceiling is 15. Okay? So from the floor to the bottom of the window, it's B feet. The window is 6 feet tall. From the top of the window to the ceiling, it's A feet tall. And the height of the room, the total height is 15 feet. So this is what we are given. They also gave you the equation over here. And A, which variable is independent based on the equation given? So let's see. You have A equals 15 minus B plus 6. You're solving for A, and the value of A depends on the value of B. Therefore, A is your dependent variable. So B is your independent variable. So to answer this question, B. The answer is B. The B is the independent variable. Okay, letter B. If the architect wants B to be 3, what does this mean? Remember, B is the distance from the distance between the floor and the bottom of the window. So that means the bottom of the window. So bottom of window is 3 feet from the floor. What would A would work with the given value for B? So let's sketch it again here. Let's see. Remember, this is our window. our window is 6 feet tall, and they want this bottom of the window to be 3 feet from the floor. So this is 3. And we know that the total height here is 15. So ask yourself, 3 plus 6 plus A equals 15. So 3 plus 6 is 9, plus A equals 15. So 9 plus A equals 15. A equals 6. So that means the distance from the top of the window to the ceiling is 6 feet. So when B is 3, A is 6. Okay, letter C. Now, they're changing it now. They want the window to have 5 feet of space above it. So above it, 5 feet. They want this to be 5 feet now. So let me sketch it here again. Okay, this is the floor. This is the window. Remember, the window is 6 feet tall. So this is 6 feet. This is 6 feet. And the overall is 15. Remember, the room is 15 feet tall. So they want this space here from the top of the window to the ceiling to be 5 feet. So this is going to be 5. Is the customer describing A or B? So the distance from the top of the window to the ceiling, is that A or B? That is A. So A for part A. And then the second one, what is the value of the other variable? So, meaning what's going to be the distance of the bottom of the window to the floor. So let's see. It's like asking yourself, 5 plus 6 plus B equals 15. So 5 plus 6 is 11 plus B equals 15. So B equals 11 plus what equals 15? 4. So this, the bottom of the window will be 4 feet from the floor if they want it. You want the space above the window to be 5 feet. Okay? All right. So for problems like this, it will be helpful when you make a sketch like this, and then you label it, so you can see what's going on. All right. So I hope you'll do your homework so you can turn it in on time. All right. I'll see you in class. Goodbye.